Welcome to section 3.1, linear equations and rectangular coordinates. In this chapter, we will begin the basics of graphing. One of the things I want you to understand by the end of this class is that graphs have meaning. They are not just pictures that your math teachers are picky about. What's actually going on is we're going to be quote-unquote solving linear equations in two variables. Instead of just having x like we had in the last chapter, we have x and y. Why does that make a difference? Because technically, all of these have infinite solutions. If I give you an x value and you plug it in, you can find a y value that would also make it correct. So there are infinite solutions, but not everything will work. Infinite, but not everything, okay? So we solve these by graphing them, and the graph itself represents every single possible solution to the equation, okay? We write those individual solutions as ordered pairs. It's always x and then y, and they go in alphabetical order. I know this looks like interval notation. It's the context of the problem that's going to tell you whether it's interval notation or if it's an ordered pair. I know it is a bit confusing, but the context of the problem should tell you which one it is you're supposed to be using. All of your graphs of these things, just like the name implies, linear, these make a straight line. Of course, there are other graphs that are not straight, other kinds of equations that are not, okay? What we want to do in these first problems, this is just kind of to give you a good feel about how things are going. All they're asking us to do is to check whether or not these ordered pairs are solutions to these equations. All we have to do is to plug in 4 for x, because x comes first, 2 for y, and then if we do the arithmetic and we get something that is true, it was a solution. If we get something that is false, it's not a solution. So let's take and we plug in these values, and we would get 2 times x, x is 4, minus y, and y is 2. And I'm hoping that equals 6. That's a question mark there. Remember your order of operations. We need to do the multiplication first. 2 times 4 is 8. 8 minus 2 is 6. 8 minus 2 really is 6, and I get 6 equals 6, which is true. So is 4, 2 one of the solutions to this equation? Yes. Okay. Let's look at the next problem. It's the same type of problem. We're being asked to decide whether 5, 2 is a solution to this particular equation. Again, we plug in the first value for x, so 5 is x, 2 is going to be y. We plug in the values and see if it makes sense. So this would be 5 times x, and x is 5, minus 3 times y, and y is 2, and I want to see if that is equal to 15. Remember your order of operations. Do your multiplication first. 5 times 5 would be 25, minus 3 times 2 is 6. Is that equal to 15? Well, 25 minus 6 is 19. Is 19 equal to 15? No. So this one is not a solution. That means that the graph of this line would not go through this ordered pair.